Okay, so say we have already finished our mechanical analysis of the linking rod. Now we're going to do a thermal analysis. So we're going to go to a new project from an existing geometry all the way down to broad sample geometries. Find the linking rod, open the linking rod geometry. This is the one that we want to analyze. Start a new project, and this time thermal. So thermal projects need a thermal conductivity and whether if it's there an internal heat source or not. So in most cases it's not. Internal heat sources are sources within the bulk of the geometry and might come, for example, from electrical heating or nuclear fission, something like that. In most cases the internal heat source is zero, and the thermal conductivity of 50 watts per meter per Kelvin is like an average conductivity for steel. Now we are going to set the ambient. Say we want to compute what happens when this linking rod is, I don't know, inside the internal combustion engine in contact with the oil. Say the oil is, I don't know, 100 degrees, and the coefficient will be something like this, for example, transfer coefficient for convection. We can add a temperature condition. Let's say that this internal surface is in contact with the piston, so it might have a higher temperature, something like that. We are done. So we have a thermal project here with a fixed temperature here and a convection condition at the rest. So next step will be meshing. Meshing for thermal projects with first order is fine. So then we will just refine a little bit, but that's all we need. So it meshes quickly, the mesh is fine, it's nice, and the solution of the problem is also very fast because it's far easier to solve a thermal conduction problem than a mechanical one. So that's it. We have the temperature distribution, we can download the VTK, we can again change the scale, we can see this, but thermal conduction problems are far simpler than the mechanical counterparts. So we're going to finish this tutorial now, but then we are going to do a thermomechanical analysis using this temperature distribution to compute stresses and displacements out of this.